So in today's session, we will try to talk about these points. Why machine learning? What is machine learning? Applications, types of machine learning, supervised, unsupervised, and different terms which are related to machine learning. So we will try to finish this particular unit, or maybe as many points possible as from this unit, because as I told you, this is not going to require much of time to finish. Right, this particular unit is not going to require maybe till tomorrow we'll be finished with this one, and maybe one more session we will take for this, right? Because it is just a, as per your syllabus they are just mentioning it to discuss these concepts. Maybe even I have shown implementations also, but yes, these 2 units we will be trying to finish. So let me start with this particular thing, introduction to machine learning. So I hope everyone is able to hear me. Okay, so yeah, meanwhile, as usual, if you have any question, just type the question in the chat box. So what I will do is I will just try to explain this with a simple diagram. We will try to see different terms which are related to machine learning, and then we will try to clear what is machine learning actually, and what differentiates machine learning from other things or other terms. See, those people who are asking me about the PCA algorithm, this one, these topics are remaining. Don't worry about this. I told you that I will finish this one first. Just try to understand whatever I am doing. I'm just trying to doing it because you should be able to understand these topics. As I told you, in your syllabus, they should have actually mentioned other topics also which are not mentioned. So people, don't worry about this. Whatever is remaining from first unit, I am going to discuss that. Okay. So, but you are going to require these things to understand this one. I do not know why in your syllabus they have mentioned it like this. Okay, so don't worry. I am going right way. Okay, you have to believe me. Don't worry about that. I will be covering. Yes. So let's try to talk about this particular unit. I will again repeat, those people who joined late. I will be discussing dimensional reduction technique, that is PCA. This is remaining. Distributed stochastic neighborhood embedding. Again, it will not require much of time. Case study. Any case study you can take based on some algorithm. Okay. So this will require maybe one session. You will have to finish that. Don't worry about that. But you are going to require these things to understand these. That's why I'm discussing these ones. Okay. Let me start it. Basic ones. NumPy is completed. Yes, Sharon, NumPy is completed. Even NumPy is not mentioned in your syllabus. Still, I have discussed that. Why? Because you should be able to understand all these points. Is it right? So, yes, NumPy is done. As per your syllabus and all that which is needed for industry related. No, see, NumPy has no end. Sharon, who is asking me, Sharon. In your syllabus, I will have to go to according to your syllabus also. I cannot discuss each and everything about NumPy, because if you talk about NumPy and industry related things, there are a lot of things to discuss about that. But as per your syllabus, whatever is needed to understand all these things, yes, sure, and that is done. But if you are talking about projects and all those things, that will require time. Okay, so maybe if you want to learn that, then yeah, definitely it will require time, because let me tell you, when I conduct trainings of machine learning and data science, it is of 3 months, right? Or generally, whenever I conduct workshops also, 1 week workshop or something like that. So daily it is near about 5 to 6 hours of workshop, 35-40 hours it requires to complete everything. But yeah, let's see. What I will do is, first of all, I will try to complete all these things as per your syllabus, because there is a system you people also need to follow. I also need to follow. We will try to finish all these things, and then if there is a time, I will definitely go and I will try to show. Even I will try to show projects also. Okay, how to develop models, how to deploy models on the cloud. But yes, and at least for your examination, as it's approaching, let me try to finish as per your syllabus, because there is a system in your case and you need to follow that. So, let me start with machine learning, second unit. So here what I will do, we will try to differentiate machine learning with other terms, or we will try to see from where actually it has come. And then in a short, in a brief, we will try to see what is machine learning actually. So see, we will try to differentiate all this stuff. So first of all, what is machine learning? As per your syllabus, they have mentioned this particular topic, and there are a lot of definitions which are possible. If you go and if you try to read in a book, you will see a lot of definitions which are related to machine learning. But before discussing about machine learning, one should be aware about what is artificial intelligence, right? What is AI? Because see, what happens is everything is actually going to come under AI only. I have seen many people, even experienced people, they have confusion about this. Artificial intelligence. That's why I'm trying to discuss this particular term also. What is artificial intelligence or AI? Along with this, we will see what is this deep learning and where actually it comes into the picture, so that it will help you to understand the difference between machine learning and deep learning, right? And obviously, one more term is there which you might have heard many times. That is nothing but data science. That is the name of your subject, right? So what is the difference between data science and machine learning? Let's try to talk about that particular topic. Okay, so in a brief, in a short, we will try to see these things, and you might have seen that particular Venn diagram in many books or many sessions, or you might have attended. Okay, so the same thing I am trying to do here also. So let me first of all try to talk about AI, because artificial intelligence or AI is the bigger umbrella. This is the thing under which everything is going to come into picture. So see, suppose if I go and if I try to represent artificial intelligence with this particular diagram or something like this is circle. So if, if this is artificial intelligence, so no, what is artificial intelligence in a brief if I want to tell you? So it is nothing but to enable computers to think. That's it. That's what artificial intelligence is. That so to enable computers to think. That's what AI is. Obviously, AI is a very huge domain. Okay, there is no end to AI. So to enable computers to think like humans, I can say, that is nothing but artificial intelligence. In a in short, in simple words, I can say, right? So AI is nothing but to enable computers to think like humans. That's what artificial intelligence is. And as I told you that artificial intelligence is a bigger umbrella. That means everything is going to come under AI only. Now, as our topic is machine learning, let's see where this machine learning is going to come into picture, as we are talking about artificial intelligence. So if artificial intelligence is clear, AI is nothing but to enable computers to think. Now let's see where this ML is going to come into picture. So ML is going to be inside AI. ML is actually a part of artificial intelligence. Again, there are a lot of definitions for machine learning which are also possible. So first of all, let's see in a short what is ML. So ML in a short, in a brief, I can say it is just a bunch of tools, or to be more precise, I can say it's a bunch of statistical tools. Okay, so machine learning is nothing but a bunch of statistical tools to learn, right? Now to learn from what? So initially when we started with this particular subject, so we have seen the terms like data, information, database, DBMS, and all these things, right? So machine learning is a bunch of statistical tools to learn from data. That's how I can define machine learning in simple words. ML is nothing but a bunch of statistical tools to learn from data. What are the bunch of statistical tools that we will try to talk about? Okay, so in a short, in simple words, this is what machine learning is. I know there are a lot of definitions of machine learning possible, but in simple words, I hope this is how I can tell you in simple words, so that you people will be able to make sense out of all these things. Right? What is AI? What is machine learning? How to differentiate that? So you can see that in this particular diagram, machine learning is inside artificial intelligence, right? Now let's see where this deep learning is going to come. Right. So as we talked about AI, ML, so deep learning is going to come inside ML, inside machine learning, right? So you might have seen many people saying that okay, if you want to learn about deep learning, you need to learn about machine learning. To some extent, definitely, I can say yes, that is true. So deep learning is inside ML, which is inside artificial intelligence. Let's see again in a short. What is deep learning? So deep learning, if you talk about, it's a much more recent term. Maybe since 2006 or 7 it is there. Okay, as compared to ML or data science or AI, I can say, AI or ML, I can say. Okay, and deep learning is nothing but what it is all about using something called as you might have heard about this one, multi-layered neural network. This is not our topic actually, multi-layered neural network. So it is related to deep learning, but you have a topic called as neural network in your syllabus. Maybe at that time I will give a simple introduction to what is neural network, which is related to neurons. Neuron is nothing but which is there in human body, because of which we are able to sense something, because of which we are able to transfer the information. Our human body, uh, we are able to transfer information from one neuron to other neuron. Neurons are present in human body, all parts of human body, not only in brain. Okay, again, that's a again totally different story. But yes, as we are talking about deep learning again, so deep learning is about something about multi-layered neural network. And right now there is a huge impact of something which is huge impact of artificial intelligence, what people refer to it as Google's artificial intelligence system. You might have heard about this. Maybe some of you might have heard about this one, Google's artificial intelligence systems. Right now, as we are talking about Google's artificial intelligence system, which is a very recent term and which is a very famous thing, talking about Google. So Google's artificial intelligence systems, they are mostly referring to Google's deep learning system. That's how the impact of deep learning is. Okay. So Google's artificial intelligence systems are mostly referring to Google's deep learning systems. So this one is actually based on Google's deep learning system. So some of the most important advances in artificial intelligence in last 10 to 12 years, which are happening, they have been happening in the small area, and that is called as deep learning. Okay, so just try to understand that. Okay. So I can see 60 people have joined, 58 people have joined till now. So see, let me just make a clear point here. Let me tell you, there will be 2 units for your midterm exam, right? And this is from second unit. And whatever I am discussing today, it is very very important. Your exam will be objective exam, right? So most of the questions will be based on this particular topic. That's why everyone should be able to understand this. Okay, obviously there will be questions on R and Python, but whatever I am discussing, just this video is very very important. Okay, just try to notice that there will be 2 units for your midterm exam available. Okay. So yes, this is what the deep learning is. I hope you got a basic idea about what is deep learning. Now, as we talked about machine learning, artificial intelligence, and deep learning, let's see what is this data science stuff. What is this one? Now, first of all, let's see where data science is going to come into picture. Now, again, here you will see that there are different definitions which are possible, or you might have seen many people saying that the AI and data science are exactly the same, or data science comes under AI. To some extent, definitely, I can say it is right. But to be more precise, or what I prefer is that, or mean, if you go try to refer standard books, you'll see that data science, they are going to represent data science something like this. Okay, which is going to cut AI, which is going to cut ML, which is going to cut DL, right? So, but yes, that is also true. If someone is saying that AI and data science, they are overlapping each other, I'm not saying that that is totally wrong. That's also true. But to be more precise, I can say that data science is going to be somewhere here, right? So, what is data science actually? So, see, from the figure, from this particular Venn diagram kind of a thing, you can see that data science has some overlap with artificial intelligence technique, right? Some overlap with machine learning techniques, and not so much overlap with deep learning techniques. From the figure itself, you can see that, right? So someone is asking, Kulbhushan Borse is asking, answer, how far we from implementing ASI, artificial super intelligence? So see, that is actually going on. The companies like Google, Microsoft, they are already working on that. Are you getting my point? So over definitely there are different companies that are working in that particular in the projects which are related to ASI, artificial super intelligence. Kulbhushan, are you getting? It is not like that there is no work going on that. That is going on. But just to make sense out of that, to come up with different projects, all these things are the basic things which are required for that. Right? Even you will see that later on we will talk about different types of machine learning. In that case, you will see something called as reinforcement learning, which is not mentioned in your syllabus, but still work is going on in case of reinforcement learning. The best example of reinforcement learning is driverless cars, right? So yeah, that is also there. So I will talk about that. Okay. So data science, you can see the overlap with AI ML, but very little overlap with deep learning here, right? But other than this, data science also has other areas, and that is nothing but this. This is so I so that's why I said that if people are saying that okay, AI and data science are exactly same, to some extent that is right. I am not saying that it is absolutely wrong. But to be more precise, data science has this area. Okay, so in a nutshell, what is data science? Data science is all about understanding, or I can say it is all about making sense of data. Okay, so whatever I have written here, just try to understand all of it, or maybe you can go and you can note down all these things. These are very, very important. There will be questions based on all these things, whatever I have. However, I have defined all these terms. The way I have defined all these terms, there will be questions based on this. I will agree. Okay. So making sense of data is nothing but data science. And you might have come across, or we have already seen in the first unit itself, that is called as visualization. Right? We talked about visualization or visualizing. So visualizing data is a very important aspect of data science. Right? And for all these areas, machine learning, data science, artificial intelligence, uh, deep learning. To talk about anything, for all these areas, there are some fundamental tools which are required, or I can say some statistical tools which are actually required for all these areas. So, which are the statistical tools or fundamental tools which are required? So, let's try to talk about them. Fundamental tools. So, again, here also, you might have heard many people saying that okay, if you want to learn data science, you should be very strong in mathematics. If you want to learn data science, machine learning, deep learning, AI, you should know probability. Obviously, but see, it's not like that. You should be very good with that. At least if you know the basic concepts, that will help. So I'm not saying that you should be an expert in mathematics. No, not at all. Because I have seen people from different backgrounds who are working in data science teams and machine learning teams. Right. So even though I am writing down some fundamental tools here, it's not like that you should be an expert in that. Right. At least if you have an idea, basic idea, that's going to be that's going to work actually. So which are the fundamental tools one needs to know to learn about all these things, right? So obviously probability, right? Probability is going to come into this. Probability is the fundamental tool which is required. Then there is going to come statistics. I will again repeat. Okay, you should not be an expert in all these things, but at least you should have an idea. Obviously, there is a linear algebra, right? Which we learned in school or colleges. You might have heard about something called as matrices, right? Matrix algebra. You should be good with matrix algebra. We have seen in case of NumPy arrays, we deal with two-dimensional arrays, and two-dimensional array is nothing but matrix, right? You might have heard about some methods like numerical optimization. If you are aware about this, that's good. Numerical optimization, right? And obviously, last but not the least, without computer programming, we cannot go and we cannot implement it, right? So you should have knowledge about some computer programming language, not compulsorily Python. It can be any other computer language, right? So you are aware about, suppose you are aware about Python. So we talked about R. So yes, either R or Python. You can go and you can develop the models. Even you can go and you can develop the models with the help of Java. Even you can go and you can make use of C++. And there is something right now you might have heard about something called as Ruby is there, right? So yes, there are different options which are available. So these are the fundamental tools which one should be aware about to make sense about machine learning, deep learning, data science, artificial intelligence, right? So this is in a short about what is machine learning. And see, there are a lot of applications of machine learning. We will be talking about that as it is mentioned in your syllabus when we talk about approaches of machine learning. So I hope everyone is clear about what is machine learning and its relationship with other terms. So anyone any question here, any doubt here? If you have any doubt, you can ask here itself. Otherwise, I will move forward and try to talk about the next topic, that is nothing but approaches of machine learning. So here you can see why machine learning you will get to know. Machine learning applications I will talk about. Training test, okay, this is again it will take 5 minutes only. I will be talking about this one now. Supervised, unsupervised, semi-supervised. So if anyone any doubt here, because all these topics as I told you, they are not going to require that much time. I hope everyone is clear. Okay. So yeah, no question, that means everyone is clear. So that's all about all these terms in a short. Now what I will do is I will go and I will try to talk about types of machine learning. So out of all these terms, now we want to concentrate on this one. Okay? Let's try to continue our discussion with machine learning. See, let me tell you, you talk about any one of out of this, each and every term is huge. Okay, you talk about machine learning, AI, deep learning, data science, each and every term. Even there are other terms also. There is something called as computer vision, right? Then there is something called as neural network. I told you. So neural network is going to be here, right? Then there is something called computer vision is there. We talked about, and then obviously you might have heard about chatbots and all those things. So yes, even in machine learning also you can go and you can create that chatbots and all those sentimental analysis. So that is nothing but natural language processing. Again, that can be somewhere here NLP. Okay. So yes, these also these terms are also there, but everything is going to come under AI. So AI is the bigger umbrella. That's why I told you AI is the bigger umbrella, right? So many times you will see that whatever is there in data science, same thing is there in machine learning. Almost same, but there are some domains which are going to differentiate data science from ML. Otherwise, they are same. So that's why I have shown you this more precise definition of all these terms. I hope everything is clear. Let me clear this. Okay. Now moving forward, let's try to talk about the next topic, and that is nothing but types. Okay. Types of machine learning. Actually, not types. What I will say is they are actually the approaches. See, there are different types of problems which are going to be there in the society now or in real time. Now, to solve those problems, there are different approaches. So, or people call it as types of machine learning. Let me talk about first type of machine learning, and that is nothing but supervised. Remember all these names, okay? If you are learning this first time, so remember this, supervised machine learning. As I already told you people, many questions will be based on today's session in your exam. Supervised machine learning approach. Okay. Another approach is there that is called as unsupervised machine learning approach. So generally in books you will see that they will talk about supervised and unsupervised. Okay. But yes, there is something called as semi-supervised machine learning approach also. So let's see what is the difference between all this. Semi-supervised machine learning approach. And yes, there is one more which I talked about earlier, and that is called as reinforcement, which is not mentioned in your syllabus, but yes, it is there. So reinforcement learning. Okay, let's see. Let's see what is supervised machine learning first. Now see, what is supervised machine learning? Whenever we talk about supervised machine learning, always remember for supervised learning, the data is labeled data. Now the question is, what do you mean by labeled data? Always remember the data which is in the form of rows and columns, that is labeled data. Now yes, it is there, but see what happens is whenever we talk about labeled data, each and every column will be having a name. There will be columns and there will be rows. Columns are called as features, or they are called as inputs, and rows are called as observations. Okay. Okay. Now see, these are called as observations and these are called as features. So for supervised machine learning, always remember the data is labeled data. Now what do you mean by that? That means, see, for example, there is a problem to solve. Now you need to create a model in which you have been given this data. So you have column 1, column 2, column 3, column 4, and 5 columns. Only 5 columns are there. In reality, actually there are hundreds, 200, 300, 500 columns are there. Okay. So just imagine there are 5 columns. Now column or maybe column 1 is name of the employee or name of the person. Column 2 is education of the person. Column 3 is marks scored by that person in an interview, and column 4 is nothing but maybe the address of the person. Okay, and column 5 is the salary of the person. Now you have a data set, you have 500 rows here. Now you need to create such a model. If new person comes and if he enters all these values, your model should be able to predict the salary of that employee. So salary of that particular person based on these columns. So in this case, the salary column is going to be your target column, and all the other columns are going to be your features. Okay, so in supervised machine learning you are aware about the features and the target. So what are the features here? Name, address, phone number, marks scored in the interview, and what is the target? Target here is nothing but salary. So it is called as target or output column. So that is what is called as label data. So always remember, in case of supervised machine learning, we are aware about the input as well as the output. That is called as supervised machine learning approach. Okay. Now, as we talk about supervised machine learning approach, with the help of supervised machine learning, we can solve two types of problems. First type of problem which we can solve is prediction problems. Right? The example which I have already told you, predicting the salary of a person based on his interview score, or maybe based on his current salary. Right? So we can solve prediction problems, which are also called as regression problems. Suppose if you want to predict the stock market price, you can go and you can make use of supervised machine learning approach. Okay, so I am also telling you the applications also, try to understand. Okay, and another types of problems which you can solve with the help of supervised machine learning is classification types of problems. So these two types of problems you can solve with the help of supervised machine learning approach. Okay, so now to solve prediction problems, there are different techniques which are available. So one is called as linear regression. Linear regression is a technique or the algorithm I can say which is available to solve prediction types of problems. There is something called as decision tree. Right now, under decision tree, you have 2-3 more algorithms. For example, there is something called as random forest. Random forest is actually an algorithm or technique which is based on tree. You might have heard about tree. Tree is a data structure, right? So random forest is the algorithm which is used to solve regression or prediction types of problems, which comes under supervised learning approach. Then there is something called as XGBoost algorithm, extreme gradient boost algorithm. Then there is something called as KNearest Neighbor, right? KNearest Neighbor algorithm, that is called as KNN algorithm. Then there is something called as support vector machine algorithm, right? So there are a lot of algorithms with the help of which you can go and you can solve these types of problems, right? New-based algorithm. So as I told you earlier, in my training, I talk about near about 16 to 17 algorithms for prediction as well as classification. So the list goes on. Okay. So these are the algorithms or the techniques which can be used to solve prediction and classification problems. Similarly, to solve classification problems, we have something called as logistic regression. Okay, and decision tree can solve both classification as well as prediction. Random forest also can solve both. KNN also can solve both. Then SVM also solve can both. XGBoost also solve can both types of problems. Okay, and there are other algorithms also. So whatever I have listed down here, these are some of the algorithms which can be used to solve prediction as well as classification types of problems, right? Which come under or which can be solved with the help of supervised machine learning approach. Right? What is supervised machine learning approach? Where the data is labeled data. Try to understand. In supervised machine learning approach, the data is labeled data. What is labeled data? It is the data where you are aware about the input as well as the output in advance. That is called as labeled data. I hope everything is clear about supervised machine learning approach. So there are different examples. Predict the stock market price. That problem can be solved with the help of supervised machine learning approach. Maybe predict the marks of a student which he is going to score based on his previous performance, can be solved with the help of supervised machine learning approach. Maybe predict the chance of admission of a student for MS in foreign university based on his scores in different exams like GRE, TOEFL, and so on. So see, labeled and structured data, there is a little bit of difference between them. Otherwise, they are same. Whenever we say labeled data, it means we are aware about what are the inputs and what is the output. Structured data, structure-wise, it is similar to labeled, right? You can say they are similar, but whenever I say labeled data specifically, it means that I am aware about what is going to be input and what is going to be output. I hope it's clear. Okay. Otherwise, what is the structured data? The data which can be written in the form of rows and columns. Same is the labeled data. In label data, it is actually defined as per the problem statement. That's the only difference. Otherwise, label and structure they are same. Okay. Now, yes, this is what I was talking about. So try to remember prediction as well as classification, both types of problems you can solve. Now let's try to talk about unsupervised machine learning approach. Now, what is unsupervised machine learning? In case of unsupervised machine learning, the data is not labeled data. the data is not labeled. Now what do you mean by this? So here you are aware about input as well as the output, but that is not the thing which is going to happen. So what happens is, suppose we have a lot of data points. A lot of data is there like this. Okay? Huge data is there. Now we do not know what is the input and what is the output from this data, right? So if I want to give you an example of a problem for which unsupervised machine learning can be used, it is clustering types of problems. So in case of clustering types of problems, you can make use of unsupervised machine learning approach. Now what do you mean by clustering? So always remember, clustering is nothing but grouping. So whenever, what is a cluster? Cluster is nothing but a group. So whenever you want to cluster your data, you can make use of unsupervised machine learning approach. For example, this is your data, right? This is your complete data. Now we are not aware about what is going to be the output. We are not aware about this. So you can go and you can apply some clustering algorithm, clustering technique, and you can divide this data into different clusters. For example, this is the cluster 0. This is the cluster 1. This is the cluster 2. This is the cluster 3. So in 4 clusters we divided this particular data, right? So, and earlier we were not aware about in how many clusters this particular data would be divided. It can be 2, it can be 3, it can be 4, it can be 10, it can be 100. We were not aware about that. But with the help of some clustering algorithm, we came to know that okay, this data can be divided into 4 clusters. For example, there are different students. Now I want to divide the students based on their marks. So each group is going to be one cluster. And we know generally what happens in class. In a class, there are clusters, right? There are groups of the students. It always happens in different classes. There are groups of students, right? So what is the application of this? Suppose if you go and if you try to take an example, suppose I want to tell you people that okay, there will be a class on Sunday. Look, I will not go to each one of them. What I will do is I will try to divide your class in such a way that if I know that okay, there are groups in your class, so what I will do is I will take one sample, one student from your class, and I will take to that I will tell to that student that okay, there will be class on Sunday, and I know that if I tell him, he is going to tell 10 other students in his group. Same is the case for this group. So I am going to take only 4 samples, for example. They are going to pass the message. Right? That's the use of clustering, which we call it as sampling also. Yeah. But yes, clustering is nothing but grouping. If I want to tell you which are the algorithms which can be used for clustering, the best algorithm which can be used for clustering is K-means. K-means clustering. That is one algorithm. There is another algorithm which is called as DB-scan, which are not there in your syllabus. Okay. K means so value of K is going to decide in how many clusters your data is going to be divided. And always remember this K value is most of the times or always it is going to be odd. So actually I should divide the clusters into 3 or 5 or 7 or 9. It should not be even. Okay, it should be odd. So K-means clustering is actually an algorithm which is unsupervised learning approach, which makes use of unsupervised learning approach, which is a clustering algorithm. And same can be done with the help of DB-scan algorithm also. This is also good algorithm, which is called as, if you want to tell the full form of this, it is density-based spatial clustering. Density-based spatial clustering. Density-based spatial clustering application with noise. Okay, density-based spatial clustering applications with noise. That is nothing but DB-scan. But most of the times you will see that people make use of this one. So it doesn't mean that this is not good. This is also good. Okay. So yes, talking about unsupervised machine learning approach, it is nothing but the data is not labeled. We are not aware about the input and the output in advance. The types of problems which can be solved with the help of unsupervised machine learning approach are clustering problems. Clustering is nothing but grouping, and these are the 2 algorithms or the techniques which can be used for clustering or grouping. Okay. Now moving forward and talking about the next algorithm, and that is nothing but semi-supervised machine learning approach. Now what is this? Now see again in many books you will not even see semi-supervised machine learning approach. because it is actually a combination of supervised and unsupervised. So in a short, I can say semi-supervised machine learning approach is unsupervised learning plus supervised learning. That's it. Now, what do you mean by this? It means that if you have a data like this, see, that's why I did not call it as structured data. That's why I call it as labeled data. Okay. So see, if this is your target, this column is your target, and all the other columns are your input features. Now, what will happen? Suppose for first record, this, and output is also given. For second record, input is given, but output is not given. For third record, again input is given, output is given. For fourth record, input is given, but output is not given. So for some records, you are not aware about the output, but for some records, you are aware about the output. That is nothing but semi-supervised machine learning approach. That's why I have written it like this. Unsupervised learning plus supervised learning is nothing but semi-supervised learning. I hope everyone is clear about that. Okay. Now talking about reinforcement learning approach. What do you mean by reinforcement? Let's try to talk about what do you mean by reinforcement. So reinforcement learning is also called as feedback based learning. It is also called as feedback based learning. Okay, or you can call it as reward based learning. Feedback based or reward based learning. Now why? Why the name is like this? Why the name is like feedback based learning or reward based learning? So see, what happens is, if I want to tell you the best possible example for reinforcement learning, it is robotics. Robotics is the best example for feedback based learning. Or as I told you earlier, driverless cars. Companies like Google, Microsoft, they are already working on the applications which are from reinforcement learning, right? Which are based on reinforcement learning. So driverless cars, robotics are the examples. So mixture of ML, IoT, you can say can be used in reinforcement learning. Now talking about reinforcement learning, so as I told you that robotics is the best example for this, or driverless cars is the best example for reinforcement learning. For example, see why it is called as reward based or feedback based. For example, there is a robot which is actually developed here. Now there is a training going on for this robot. Now after the training, you want to test the robot. Now that robot is supposed to move one step forward on some instruction. But if it is moving one step to the right side on a particular instruction, so at that time give negative feedback to that particular robot. So that what will happen? Or punish it, right? What will happen because of that? Because of that, it is going to remember the same mistake in future, and it is not going to do the same mistake again. And if it does that particular task correctly, give a reward to it, right? So that it will remember next time. That's why it is called as, or give a good positive feedback. If it is doing the task as per the expectation, give positive feedback. Otherwise, give negative feedback. That's why it is called feedback based learning or reward based learning. So that it is going to remember those feedbacks in future, and it is not going to repeat the same mistake again and again. That's why it is called as feedback based learning or reward based learning. So that is all about supervised machine learning approach, unsupervised machine learning approach, semi-supervised machine learning approach, and reinforcement machine learning approach. So try to remember all these names. So if anyone any doubt here, you can ask me. Right? That's what see. Types of learning: supervised, unsupervised, semi-supervised, and I have even talked about one more, that's called the reinforcement, which is not there in the syllabus. But yes, these are the four types of machine learning. Why machine learning? If I want to talk about machine learning, can solve different types of problems. It can solve prediction types of problems. That is the reason you can make use of machine learning. It can solve classification types of problems, as I told you, right? So predicting the prices of stock market price, you can go and you can predict. And even in healthcare domain, you can solve a lot of problems with the help of machine learning. For example, if you have a data of the patients, right? If you have data of the patients, what you can do is you can go and you can develop such a model which may predict, depending on the symptoms of a patient, your model will be able to predict or classify patients whether the patient is affected by some disease or not. For example, if you talk about current situation, if we have a data set available, you can go and you can identify whether the patient is positive or negative. You can go and you can classify the patients with the help of data. You can create a model in such a way that if patient enters all the symptoms, your model will be able to talk about whether that person is affected by COVID-19 or positive or not, right? So someone is asking, what do you mean by reward? Reward is nothing but the what you can say. It's like information, or see, it's like, for example, in real life, what happens is, suppose right now I'm your instructor. I'm talking about some of the points, right? Now see, what happens is, if I ask you something, if I teach you something, and after teaching only, after 5 minutes only, I ask you questions, okay, on the same topic which I just now taught you. In that case, what will happen? You may not be able to recall that, right? Because you might have heard that particular point first time. So what I will do is, I will teach you that particular point again. Second time also, if you are not able to answer, I will teach you again. Third time also, if you are not able to answer, I will teach you again. So I am trying to repeat again and again, right? So what happens is, suppose while training the robot also, in case of reinforcement learning, if robot is not doing the task as per the expectation, give a negative feedback or reward. It means what? Go and return such a value in the database, right? So that with the help of that, our model is going to come to know that, okay, the expected result and the predicted result, they are not matching. That means reward is nothing but send false, so that your robot or model is going to remember that particular thing in future, and it will not do the same mistake again. Same whatever we do in case of if example. So as a student, if you are not giving correct answer, that means what? That means there is some problem, maybe in my teaching, or maybe you people while learning, right? So what I will do is, whenever you people are not able to answer it correctly, I will ask you question again and again, so that, and maybe I will give some punishment, so that you will remember it whenever it is needed, or you will remember it for longer time. Is it clear, Sharan? That's what reward. So they have used a term called as reward, right? So in programming language, you can say, you can go and you can send a flag. So I hope everyone is clear about all these points. Now talking about this one, talking about training versus testing. What happens is, maybe for this one I will be showing you one model. Okay, I have already deployed some of the models. Maybe I will try to show it to you. See, what happens is, what is the training and testing? See, initially, whenever in our case, let me tell you, whenever client comes to us, and client, if they want to develop a model, so what they do is, first of all, they send us data. That's why we started with data. Now this data can be in different formats. This data can be in CSV file, this data can be in Excel file, this data can be from some MySQL, from some database like MySQL or Oracle or any other database, right? Maybe from JSON file, or for that matter, Cassandra, Hadoop, any other database, right? Now from that data, our target is what? Our target is to create a model, right? So I want to finally create a model. Suppose client has come to you, client wants to create a model. For what? To solve some problem. What type of problem? Suppose client wants to create such a model which is going to predict chance of admission of a student for MS in foreign university based on his marks in GRE exam, based on his marks in TOEFL exam, based on his marks on statement of purpose, whatever the project he has done, based on the rating of university in which he finished his graduation, and so on. They want to create such a model which is going to predict chance of admission of that student in foreign university for MS. So they send us some data. Now what are we going to do with the data is, we gonna, first of all, we are going to clean that data. We are going to do everything, right? So first of all, we are going to clean that data. We are going to fetch that data first, then clean that data, remove any values, all those things. Or I can call it as pre-processing. we're gonna apply pre-processing techniques on this. Okay. Once that is done, once we apply pre-processing technique, now your data is going to be here. Okay. Now, talking about this training and testing. So as we want to train the model, we need some data. Let's suppose there are 100 rows. Obviously, 100 rows is a very small value. Okay. But just for your understanding purpose, I am taking it as 100. So there are 100 rows in your data. Out of these 100 rows, see, obviously there will be input as well as the output in this data. Some columns will be input and one column will be output, right? So what are we going to do is we are going to divide this particular data into input and output. Input I will name it as X and output I will name it as Y. Remember, try to understand. Input, whenever I say, it will be more number of columns. Output will be only one column. Okay, try to understand. Output will be only one column. So suppose GRE score, total score, SOPM, segment of purpose and university rating. These are assigned to X. And chance of admission is assigned to Y. Try to understand. Okay. So more than one column are assigned to X and only one column, that is output, is assigned to Y. Input and output. Now, how many records we have? 100. So obviously there will be 100 rows here, 100 rows here. Now this input we gonna divide it into different parts. This output also we are going to divide. So what happens is we are going to divide this input into training and testing. So we are going to divide this into training and testing. Same is the case for training and testing here also. Now, generally what happens is generally 70% of the data we take it as training and remaining 30% of the data we take it as testing. But this is not hard and fast. It can be 85-15. It can be 80-20 also. It can be 75-25 also. Okay, it's not hard and fast. It all depends on data. So we will take 70-30 for example. Okay, now as we take on 70% of data, so I will name it as, so as it's a input data, so I will name it as X train. Okay, as this is the input data but testing data, so I will name it as X test. Similarly, output data, so Y train. And what is going to happen here? This is Y test. Okay. Now, how many records will be there? 70. How many records will be here? X test. So again here it is 70. Out of 100, 70%, right? So sorry, it is test data, right? So for test we take 30%. So X test will be 30. This will be 70. As it is training, that's a 70. As it is testing, that's a 30. As it is training, that's a 70. As it is testing, that's a 30. Right? Now, after this, what are we going to do is, based on this training data, what is the training data? X train and Y train. Based on this training data, we are going to make use of some model. For example, linear regression. We want to make use of linear regression on this, and we are going to come up with a model, this model. And once the model is done, maybe you can develop the model in Python language, R language, whatever you want, Java, whatever. Once that model is developed, now we want to check what is the performance of the model. So to test that model, now we're gonna make use of testing data. So this test data and this data. So this is what? This is test data, but input test data X. So this input, this X underscore test, this will be passed as input to this model, right? Actual output is what? Y. So as X test we pass, we are going to get Y prediction. So this is the result by our model. This is the actual result. So whatever we got, actual result minus the result by our model, that is going to be our error, right? And our target will be to minimize this. Okay, and that's why we have done it as training and testing. So generally we do it like this. Okay, so in simple words, that's how I explained you the complete process of creating a model, which involves training and testing, and that's why we make use of training data. So what is training data actually? What is training data? It's like if you take an example of a newborn baby, so how we teach newborn baby, so we try to show him different things, right? Suppose if you want to teach him how bat looks like, so what we will do? we will try to show him different bags, maybe pictures of bags, maybe original bags, and then we will ask him to check, okay, is it the bag? He should be able to identify, yes, it's a bag. If he is not, then you need to show him more images. It's a training, right? So in simple words, that's what I can tell you. Maybe we will try to talk about, we will try to make use of that. Then we will try to talk about some models. We will try to do some hands-on on models. At that time, we will try to talk about more about this one. But for your theoretical point, yes, that's what the concept of training is. Okay, I hope it's clear to everyone. So maybe in the next session we will try to finish this particular second unit itself, and then we will talk about the remaining points in the next coming unit. Okay. So now I can say 69 people are there. So for your midterm exam, there are two units, this one and this one. There will be questions based on R. There will be questions based on Python. There will be questions based on ML, types of ML, whatever I talked about today. All the questions will be objective. And whatever I have mentioned, I have shared some files with you people, right? I told you that, even on group also I told you that the videos which I have shared with you people on my YouTube channel, right? Below those videos you'll be able to find out all the documents. So those documents are very important. The documents which I shared you as a notes and which I shared you as tests which we saw. They are very important. You will be able, you will see some of the questions or most of the questions from those documents. Same for R and same for Python. And whatever I talked about today, those topics are very important. Based on them, also there will be objective question. Okay. I hope everyone is clear.